All right, so today we are dividing monomials. So yeah, the other day we did multiplication. Today we are doing dividing. So we're gonna learn a new rule, and you'll notice that it is very similar to multiplying, but kind of opposite. So the first thing is dividing powers. So I'm just gonna show you what this looks like if we were to write it in expanded form and then rewrite it in exponential form. So if I take, so this is x to the fifth divided by x to the third. So I'm gonna rewrite these in expanded form. So that means I'm gonna write x, multiplying it out 5 times. Okay, that's on top. And then we have 3 down here. Okay, so if I'm dividing these, I'm gonna cancel them out. So this cancels, that cancels. We're left with these two. So we're left with x squared. So I just want you to keep that in mind before we learn the property. All right, let's try this with 2's. 2 to the 8th divided by 2 squared. So I'm gonna do 2 times 2 times 2 and on until we have 8. One more. And then down here, we need 2. All right, so I'm gonna cancel these. We're left with 6 of them. So think about that for a second. How do we get to that point? Well, let's take a look. 5 minus 3 is 2. 8 minus 2 is 6. I think we have our next property, quotient of powers. So to divide powers with the same base, they have to have the same base. You subtract the exponents. You're not dividing the exponents, you're subtracting them. So when we multiplied powers, we added the exponents. When we divide powers, we subtract the exponents. So we're gonna do some examples here. So for example 1, we have 6 to the 12th divided by 6 to the 2nd power. So what I'm gonna do, they have the same base, so I'm gonna take 6 stays the same, 12 minus 2, which leaves me with 6 to the 10th power, and they want the answer with an exponent. All right, example 2. This time I'm looking at variables here, matching the variables with its match. So a to the 14th divided by a to the 8th. What you're really doing is 14 minus 8 times, because when these are next to each other, that means multiplication. But we're not gonna actually multiply. We're just worrying about these exponents. I need to divide the b's. So I'm gonna take b stays the same. We're gonna do 10 minus 6. So our answer is going to be a to the 6th, b to the 4th. And if you want to put a little dot for multiplication in between the two, you can. I left it just like that, just how they did in the problem. All right, let's try this with numbers here. Again, they have to have the same base. So we're taking these two, and we're doing 4 minus 2. When we do that, we get 3 squared. Now this time I am gonna put the dot, because if you put numbers next to each other, it's not gonna be multiplication. You have to have the symbol. Next we're doing the 5s. Remember, this doesn't have a number here, but that means there's a 1. 2 minus 1 is just 1. You can just write 5. If you wanna put a 1 there, you can. And then the last one, 5 minus 3 is 2. Now, you could simplify this and do it in your calculator and get an answer, but they don't want it like that. They want exponents. All right, example 4. This one has coefficients. So you are gonna take the numbers and divide them, and then you are going to take the variables and do what we were doing earlier with them. So I'm gonna rewrite this with different colors again. So we have 18 divided by 2. And then we have the x's that go together. So when I solve this, 18 divided by 2 is 9. 9 minus 6 is 3. So our answer is 9x to the third. Okay. For the next one, just numbers again. Negative 2 to the fifth divided by negative 2 to the second. So we're going to keep negative 2. Now we're just doing 5 minus 2, which is 3. Same with our 3's. 3 is going to stay the same. 4 minus 1 is 3. For the 5, we do 7 minus 4, which is 3. And example 6, I see a coefficient number in front and I see variables, so I'm going to use 2 different colors here. So we have 9 divided by 3. Then we have x to the 6th divided by x to the 4th. So when I divide these, 9 divided by 3 is 3. Same bases, we subtract, so we get x squared. All right, let's try this word problem. Hawaii's total shoreline is about 2 to the 10th miles long. New Hampshire's shoreline is about 2 to the 7th miles long. About how many times longer is Hawaii's shoreline than New Hampshire's? So we want to figure out how many times bigger it is. If we already have the total for Hawaii, we need to figure out the difference there. But for this, we're going to divide it. So I'm going to take Hawaii's total shoreline, which was 2 to the 10th power, and divide it by 2 to the 7th power, which was New Hampshire. So because they have the same base, we're going to do 10 minus 7. We get 2 to the 3rd power. So it's 2 to the 3rd miles longer. So you just gotta be careful with the wording and the word problems. All right, so the rule for today was quotient of powers. So remember, when you're dividing powers, if you have the same base, you subtract the exponents. So you need to be careful with that. Keep your properties straight because you are going to learn more of them soon. Use this when you're doing your homework. If you have any questions, please reach out. And I hope you enjoyed this lesson.